Dear students, I welcome all the students of BSc Agriculture on behalf of Amity Institute of Organic Agriculture. In the class of Soil Fertility Management, today we are discussing about carbon sequestration. What is carbon sink and what is carbon dynamics? How carbon dioxide changes their forms, how carbon changes their forms, and how their amount is varying in different environment. We will study in details. So you already know carbon dioxide is a major pollutant of air pollution. These are the sources of pollution or carbon dioxide. Chimneys are there, forest fire is there, paddy crops and vehicles, also sewage dumping places are there. These are the sources of carbon dioxide emissions. They are coming out from these sources. So greenhouse gases, emission of greenhouse gases is taking place, and due to emissions of harmful gases, global temperature is increasing. And it is expected that in the 21st century, the temperature will rise by 1.1 degree to 6.4 degrees Celsius by the end of 21st century. So a global warming of more than 2 degrees Celsius increase in the average temperature will lead to serious consequences. There will be serious result if average temperature rises by 2 degrees Celsius all over the world. So global greenhouse gas emissions must be reduced by 50 to 80% by 2050. Means within 30 years we have to bring down the greenhouse gases emissions by 50 to 80%. This is as per IPCC, Intergovernmental Panel on Climate Change. This is IPCC. So CO2 level has increased over 40% from 280 ppm in the pre-industrial time to the current over 400 ppm since 2013. This is also the report of Intergovernmental Panel on Climate Change, and this is the fourth assessment report of climate change. So this is the photographs. These are the extreme, maximum or highest historical carbon dioxide levels. You can see 0 means 1950. From this level, at present level, the carbon dioxide level is more than 400 ppm. This is highest at present. Before this current time, it was highest about 125 years back, when it was 280 ppm. Again it was around 270 ppm about 250 years back. About 325 years back it was around 300 ppm. Around 4 years back it was around 280 ppm. So it was 280 ppm during pre-industrial area, before the industrial revolution, before many industries were have not been established. After industrial era, CO2 levels suddenly increased by 40%, sudden increase, and current CO2 level is over 400 ppm. So we have our targets. IPCC, Intergovernmental Panel on Climate Change, they have set a target for humanity to do the implementation, to implement the policies so that the temperature rise should be less than 2 degrees C. That CO2 emissions should be reduced globally by 41 to 72% by 2050. We should minimize the CO2 level by 41 to 72% by 2050. We should minimize all greenhouse gases by 50 to 80%. We should enhance energy efficiency and increase renewable energy production that will reduce the CO2 emissions. It does not have the potential. However, there is great demand, so there is no potential presently. We are looking not optimistic that CO2 level will be controlled. So what should be done? What are our new approaches that should be taken care? We have to improve our energy efficiency, promote energy conservation. We have to increase usage of low carbon fuels, including natural gas, hydrogen or nuclear power. We should deploy renewable sources of energy such as solar energy, wind energy. After geoengineering approaches, afforestation and reforestation should be continuously done. CO2 capture and storage. Although this is a costly approach, but this is successfully done in about 10 centers of the world. Now, comparison of CO2 reducing a strategy. The simplest form is afforestation and reforestation. This is the simplest. The costlier and tough technology is carbon capture and storage. We can capture carbon more than 80%, although it is very expensive technology, but it is available. This is called carbon capture storage. So this technology can capture up to 90% of the carbon dioxide or more than 80%. They prevent from entering into atmosphere. The chain consists of three parts. Number 1 is capture, number 2 is transportation, number 3 is a store. So there are three chains involved in CCS technology. CCS means carbon capture and storage. These are the photographs. This is methane. This goes to reformer and more than 99% carbon dioxide is here. They can react with water and they can be captured. Post combustion. After combustion, we can see loss of 15% carbon dioxide. They are separated. Number 3 is OXYFUEL. Oxygen fuel, oxygen is burning. Combustion it is also called, and the level of carbon dioxide is over 90%. This is pre-combustion, means before burning the carbon dioxide is mixed with hydrogen. So it is forming carbon dioxide or hydrogen carbonate. Post-combustion, when CO2 is captured from the exhaust of a combustion process by absorbing it on a suitable solvent. The absorbed CO2 is liberated from the solvent and is compressed to transportation and storage. So these are the photographs of post-combustion. Carbon dioxide plus nitrogen plus water are stored. OXYFUEL. Oxygen is a burner. They can burn and emit carbon dioxide. Carbon dioxide is also compressed to make many efficient transport system. Denser the CO2, more easy to understand it. Compression graph. Compression graph is prepared between temperature and pressure. Higher the pressure and at lower temperature and higher pressure. Suppose if the pressure is around 9000 and temperature is 250 Kelvin, then there will be solid state. If the pressure is between 10 to 1000 bar, then the composition is called liquid. CO2 transport. Once CO2 is captured in a device, it is compressed into liquid state and dehydrated for transport and storage. These are dehydrated, these are supplied to other nations and they are carried through boats, through oceans. Carbon sequestration is a word which is also known as carbon capture. Geoengineering technique for the long-term storage carbon dioxide for mitigation of global warming. So we can control global warming with the help of carbon sequestration or carbon capture. How can we store carbon? In plants and soils, terrestrial sequestration. Carbon 6. Underground geological sequestration. Deep in ocean sequestration as a solid material. So different sequestrations are there, out of which terrestrial sequestration is the biggest factor. The process through which carbon dioxide from the atmosphere is absorbed naturally through photosynthesis, stored as carbon in biomass and soils. How can we reduce greenhouse gases? We can maintain the carbon storage in trees and soils. We can increase carbon storage in tree planting and conversion. From conventional to conservation tillage practices on agricultural lands should be done. Geological sequestration. This is underground changes of carbon dioxide. Carbon dioxide undergo in rock formalities in several small pore spaces. Carbon dioxide is also injected at a pressure into pore space at different depths and the reading is noted. Underground storage include injecting CO2, oil fields, gas fields, saline formations, sandstone reservoirs. These are the photographs of different altitude and latitude. Benefits of geological sequestration: less erosion, increased soil fertility, improved soil structure, healthier entomology, improved agricultural performance. Ocean sequestration. This is the largest place. Ocean has 50 times larger carbon sequestration than the Gulf. Ocean is a large sink of carbon dioxide. About one-third of carbon dioxide emitted each year is sink into the ocean. Ocean has 15 times more carbon than atmosphere or other sources. Pollutants are more danger for soil science. We must be careful about that. Even not the pesticides and insecticides, but others are also. Negative impact of carbon capture system. Carbon capture and storage system. They can damage the environment if they leak. The technology used in carbon capture and storage can also be used as certain aspect of air pollution. Technology is very expensive and largely unapproved. Ocean sequestration can lead to a common acidification and thus lead to coral bleaching. So due to sequestration in ocean, there are two cases. Number one is acidification. Ocean is pH is going down, so it is called ocean acidification. And second is bleaching of coral, beautiful corals. Unless human beings do not interact, this coral bleaching is taking place. So the overall conclusion is that carbon capturing and storage device is very costly, so it is not easy to install. There is a need of more research with help of securing the storage and other protection techniques. Success of carbon capturing system and storage project depends on encouraging other nations in developing and using CCS technology. These are the differences now we can discuss.